welcome to Sunday's edition of Cracking the Cryptic, where today we've got a puzzle by Dying Flutchman to take a look at. It's called Imposter Digit. I've read the rules and they seem very interesting indeed. A couple of the testers had a go at this. One of them actually failed to solve it. And the other one did solve it and said it's a very beautiful puzzle indeed. So I think we should be in for a treat, although it might be quite a challenging puzzle. I'll read you the rules in just a second or two. A couple of things to mention first. This evening at 10 o'clock UK time, Mark and I are going to be attempting a game called The Looker, which apparently is a parody of The Witness, which we've streamed before. So we're looking forward to having a go at that, and we'd love to have your company. So 10 o'clock UK time, if you have any interest in watching Mark and I try a computer game. Then next thing is Domino Sudoku is out. So this is very exciting news. This is our new app, and it's it's only out on the App Store at the moment. We hope by the end of this week it will be out on Android, and then it'll probably take a couple more weeks for it to be out on Steam for PC and Mac. Steam's procedures take longer. So yeah, do download it. If you like it, please give it a great review. We'd really appreciate it. The feedback we've already been getting for those of you who've downloaded it and tried the puzzles already has been stellar, as predicted, to be honest, because the puzzles are made by some of the great and good of the Sudoku community. So loads of handcrafted, beautiful Sudokus. Now, what else? Loads more of you have managed to solve Joseph Nehme's Patreon reward for the month. So I need to say congratulations to Christina, to Scott Abercrombie, to David Vance, Andrea Becerro, Stuart Crichton, Paul Paulauskas, maybe, Ewan McNeil, Georgie Matty, Marcus Zockel, John Forsyth, Monica L., Alan Bagg, Nick Ellis, Parker Bond, and Awesome Sauce. All of you correct. Very well done. And if you haven't checked out that pack yet, do have a look at it. It has been getting rave reviews and is a lot of fun. Is it It is. Well, it's 13 puzzles in all. Some of them are definitely approachable. Some of the ones at the harder end are more challenging, but I've been pleased to read that loads of you have been helping each other over on the Discord server, so if you do get stuck, there is help available. And finally, very happy birthday today to Dan from your girlfriend Kim over in Washington DC. So I think you're headed to the beach this weekend to celebrate, if I'm not mistaken. Very nice too, and I hope you have a brilliant time, and of course loads and loads of cake. Now that all said and done, let's have a look at Imposter Digit. I'll read you these rules. They are as follows. Normal Sudoku rules apply. Cells separated by a white dot are consecutive, so we have to put consecutive digits into these dominoes here, so a sort of domino Sudoku constraint, although it gets more complicated in a minute. Cells separated by a black dot are in a 1:2 ratio, so that means that one of those digits has to be double the other one. One of these digits has to be double the other one. Now, here's where it gets interesting. Digits in cages can't repeat and sum to the indicated total. So those those 8 cells there sum up to 40, except, however, one of the digits from 1 to 9 is an imposter. Whenever that digit appears in a cage, it counts as any value from 1 to 9 towards the cage total. This value can be different for each cage that the imposter appears in. So that means we have to work out which digit in this puzzle is basically a lying digit. So imagine the lying digit was a 1. Then imagine it appeared in this cage. That digit 1 could have any value from 1 to 9 to contribute to this 41 total, which is fairly head scrambling. But that's what we have to do. So do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. Now I can see immediately there are some cages in this puzzle that must contain an imposter digit. And that's because of the secret. Now the secret is, and it's something I only tell my favourite people, but if you're watching this video, of course you're in that set, in that Venn diagram. The secret is that any complete box of a Sudoku, any complete column, any complete row, if it's correctly completed, will contain the digits 1 to 9 once each. If you add up the digits 1 to 9, you get 45. So, because digits can't repeat in a cage, it ought to be impossible, I should say, to have a 48 cage, because the maximum size of a cage would be a 9-cell cage that contained all the digits 1 to 9, therefore, and added up to 45. So this 48 cage is definitely, well, I suppose all we know about it is it's definitely got an imposter digit in it. That cage must have an imposter digit in it. That one must have an imposter digit in it. Yes, this one is also telling us lies, because that is an 8-cell cage that apparently sums to 45, which ought to be impossible, because not all 9 Sudoku digits sum to 45, not 8 of them. So something is wrong with this cage as well. We've got an right, look at this cage. This cage hasn't got a total, but I think that's because it doesn't need a total, because that is a 9-cell cage, and therefore must contain all of the digits from 1 to 9. Well, yes, so a total for this cage would be a bit of a misnomer, because the imposter digit must appear in this cage, because it's a 9-cell cage, and could take any value. So, I mean, if this had a 50 written into it, then it wouldn't really mean anything, because we know that the real sum for that cage is 45. The whole grid is caged though, isn't it? So I wonder whether we can... We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cages all together. So hello as Maverick flies past, not quite as directly over the house as as Mavericks fly past yesterday, which really did shock some of you with its volume. I know the things I have to deal with. Right, hang on, we've got 10 cages in this puzzle. I've got 10 cages into which I've got to put 9 imposter digits. So, and I know that there's an imposter digit in this cage. So the remaining cages, of which there are 9, have to contain 8 imposter digits. And no cage can contain 2 imposter digits, because that would be repeating the imposter digit in the cage, and that's against the rules. So that means that exactly one of these cages, let me just highlight, exactly one of these cages doesn't have an imposter digit in it at all. So one of these cages doesn't have an imposter digit in it. So that we know that that cage cannot be the ones that we've identified as having imposter digits in them. So one of these yellow cages is imposter digit less. And that is very interesting, actually, straight away. So now we can say, yes, I was just counting the cells in these cages to see what they added up to. Now, look at the shapes. They all look very remarkably similar. They've all got 8 cells in them. So each of these cages is an 8-cell cage that, if it was a 9-cell cage, would sum to 45, ignoring imposters. Whereas each of these cages sums to either 40 or 41. And because one of these cages doesn't have the imposter digit in it, which means one of these cage totals is true, that means the imposter digit is either 45 minus 41 or 45 minus 40. So it's either 4 or 5. So now we actually know something about the puzzle. So the imposter digit is either 4 or 5. I wasn't expecting that for some reason. I thought the imposter digit was more likely to be 1 or 9. So if the imposter digit... So does that mean we can maths this out then? I'm just wondering what the maximum total would be for a cage if we have to replace its 4 or 5 with any other number. Right, so this is the highest cage in the puzzle. That adds up to 49, which we know includes an imposter. So, and that imposter, well, what's the maximum we can make it? If we have a real 5, have a 4 that's an imposter that we replace with a 9, that's going to give us the highest total. So 9, 8, 7, 6, 5, a 4 which counts as a 9, and a 3 and a 2. That's the maximum you could ever make an 8-cell cage in this puzzle add up to. And that would add up to 9, 8, 7, 6 and 5 add up to 35. I know that. 35 plus 9 instead of a 4 is 44. Plus 3 plus 2 is 49. That's beautiful. Right, so does that mean... I think it does mean that the imposter digit is a 4, because that... let me just put the digits in. 9, 8, 7, 6, 5 is what I said. Then a naughty 4, which we'll ring it to show how naughty it's been. And then we go 3, 2. There is no way I can make an 8-cell cage add up to more than that. So, and if instead I flick the naughtinesses around and I make the 5 the naughty digit, then I'm going to lose a potential value, aren't I? 9, 8, 7, 6 is 30, plus 9 is 39, and if I put this as 9, I get 48, which is not 49, so that's not right. So this is... oh, hang on, let me just get rid of my naughtiness indicator. So now we know that the imposter digit is 4, and we know that this cage, we know its composition. It doesn't have a 1 in it, which means there's a 1 in one of those 2 cells by Sudoku. Because there must be a 1 in box 7, obviously. So this... the other thing actually we can do here is that digit must go in one of those 2 cells, mustn't it? That digit there. Because that digit can't repeat in its cage, yet must appear somewhere in box 7. So that digit, let's unpurplify this. Well, no, we'll repurplify this one and note that this is now... yes, this is a 1 purple pair, where purple is not 1, because we can't put 1 in here. We know this cage is missing a 1. So whatever goes in here is not a 1, needs to appear in box 7, can't appear in its cage, so is in one of these digits, which we know, and this domino is... we know there's a 1 in this domino, so there is also a purple. But the problem we've got here... because I was thinking, can I now extend this to the 48? But I don't think I can. And that's because there could be a... can there be a 1 missing from there, actually? No, right, okay, so I know how we do this. I was worrying about whether or not I could miss a 1 out from here as well. But I can't miss a 1 out from the 48 cage because of Sudoku. And that's because, look at box 4 now. Now, we know this cell is not a 1. We know there's a 1 in this 41 cage. So the 1 in this box... oh, in fact, this is going to give me a digit. The one in this box has to go in these 2 cells, which means that's not a 1, which means that's a 1, which means that's not purple. Good grief. This is absolutely lovely, isn't it? So now, the thing I was interested in is I've now proved there's a 1 in the 48 cage. And if there's a 1 in the 48 cage, what is its highest total now? We know it's got an imposter digit in it. We know that imposter digit is 4. So if I max out everything else, now I think I'm going to get an absolute, we're going to hit an absolute maximum. So the maximum is going to be 35, a naughty 4, which we're going to say is going to count for 9. So that gets us to 44 again. I can put a 3 in and a 1, which gets us to 48. So that is the maximum again. So that means that this cage, let's get rid of the naughtiness indicator again. So this cage is missing a 2, which means that we can put a 2 into one of those by Sudoku. And this is going to is this going to keep going? Look at this, we've got a 49 here. We've got a 48 here, we've got a 47 here. So can I prove now that I know the 48 cage doesn't have a 2 in it, because it has a 3 and a 1 instead. Right, there's all sorts of geometry going on here as well, because this cell has to find a home in box, this cell here has to find a home in box number 1, and it can't repeat in its cage. So this is a 2 blue pair, just as this was a purple 1 pair. But now I'm wondering if I can do the same thing with 2s in here that I did with 1s in here. Where does 2 go in this box? Not in those cells. We know there's no 2 in the 48 cage, so not here. So there's a 2 in one of these, which means this cell's a 2, which means it's not blue. Good grief. This is just beautiful, isn't it? It's really clever. So now I know there's a 2 up here. But does that... that might still be difficult though. Because I was able to prove there was a 1 in this cage. But can I prove there's a 1 in that cage? I don't know. I don't think so. I know there's a 1 in here, so I know there's not a 1 in there. It's just the geometry's not helping me, is it? I can't use Sudoku anymore. So, okay. So I think that there are other ways of getting to 47. Let's just double check that then. So if we go for maxing out everything again, 9, 8, 7, 6, 5. So 35 plus a 4. We know there's an imposter digit in here, so that gets us to our 44 total. But yeah, this is where it gets tricky, because if we knew there was a 1 in this cage, then we would know this was a 1-2 pair. But if there was a 3 in here, which there could be, then these digits are naturally adding up to 35, 40, and the 4 could have the value of 7. And that would work. Ah, bobbins. Because the 4 can be anything. The 4 can be anything. So this is not clear to me, at least. So how do we... Right, okay, so maybe what I'm meant to do now is to use these black dots, look, because there's a 2 in this cage. So that means these black dots can't involve 1, 2 or 2, 4. So they have to involve 3, 6 and 4, 8. Right, so now this is interesting because now we've learned that this has an imposter digit in it. So it is not the real cage. So that loses its yellowness. In fact, we know that the cage that is real has to be a 41 total now. So these lose their yellowness. So one of these two cages is the cage that is a natural total and doesn't have a 4 in it. So now I've got 2, 3, 4, 6, 8 in here. So these cells have got to be from 1, 5, 7 and 9, which means that cell is 1, 5, 7 or 9. That cell's not 1 by Sudoku, so that cell's not 1. So this is 5, 7 or 9. There's a, oh no, there doesn't have to be a 1 in here. Because this is missing a digit, and I don't know what that digit is yet. Oh dear. Okay, I've come to an absolute grinding halt. Oh, that cell is consecutive. Ah, there you go. I've got a 1. That cell is consecutive with 5, 7 or 9. It can't be a 1. So that's got to be a 1. So this square's got to be even. It's got to be 4, 6 or 8. So actually, if that was a 4, then we would know this was the cage that was 4-less. So the way to know this is a 4 is to be able to prove this is a 5. Don't see how to do that. Oh, actually, here's something. Where does 1 go in this cage now? And it's ruled out of these 3 and these 2 cells, so it's got to be in one of those 3 cells, which means that 1... well, it would be lovely if we knew it was on this white dot. It would be lovely because I know it was a 1-2 pair, and even if it was here, it would be lovely because I know this had to be a 2. That would put a little bit of pressure on that. No, actually, it wouldn't put much pressure on that black dot. So, okay, this geometry idea that we've got in these cells is going round the grid. Look, that cell, whatever that cell is, has to find a home in this box, and it can't repeat in the cage, so it's got to go in one of those cells. It really looks like the same is true here, isn't it? So that cell has to go in one of those cells. It really looks like what I should be able to do is to extend this logic we did with the 1s and the 2s to this cage. But I don't see how to do that. To do that, I would have to know that this cage if I knew this cage had a 1 in it, then it works. Then I can do the logic. But why does this have to have a 1 in it? Oh, I know why. Hang on. This one doesn't have a 1 in it, does it? How many cages were there? So were there 10 cages? I've forgotten. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so we've got 10 cages in the puzzle. But I know this cage has got 1 of every digit in it. So into the remaining 9 cages, 5, 6, 7, 8, 9, I've got to put 8 of each digit. Oh yeah, that's it. That's beautiful. That's done it. Right, I should have spotted this absolutely from the start. Right, let's think about what that means. Because I've got to put 8 of every... I've got 9 cages in this puzzle. Yeah, they're all of size 8, aren't they? So this is the maths. A Sudoku is 9 by 9, which is 81. Once we remove a 9-cell cage from that, I get down to 72 cells I've got to fill with the remaining digits. And there are 9 cages of size 8, and 9 8s are 72. So, right. But because I've got to fill those 9 cages with 8 sets of the digits 1 to 9, because this is one set of the digits 1 to 9, I know the overall puzzle has 9 sets of the digits 1 to 9, that means that I've got to put each digit, it can only go into those 9 cages once. So let's think about the digit 1. How many of these 9 cages? How many of these 9 cages can the digit 1 go into? Well, it's got to go into 8 of them exactly. Therefore, exactly one of those cages doesn't have a 1 in. And I can't put 2 1s in any cage. So there is only one cage in this puzzle that does not contain the digit 1. Now, once... And that logic is just extendable to any digit. And because every cage is 8 cells large, every digit is missing from exactly one cage. Because if you imagine this cage obviously hasn't got a 1 in it. We worked that out at the start. So every other cage in this puzzle has a 1 in it. And then we've worked out this cage doesn't have a 2 in it, and that means every other cage in the puzzle has a 2 in it. And this really matters for this cage, because that means because this is the cage that doesn't have a 1 in it, this cage does have a 1 in it. And once this cage has a 1 in it, let's do the maths on it again, because I think we're going to find there's only one way of getting to 47. So we've got to go 9, 8, 7, 6, 5. That's the most we could go. We can go 4, and then we know there's a 1, and we know there's a 2 in the cage. So we know the 4 is the imposter. So we've got 35, 38 there, and this is an imposter, but we've got to get to a count of 47. So this has to be a 4. Well, we know it's a 4, but it has to be a 4 replaced by a 9 to correct the count, which means we now know that this cage doesn't have a 3 in it, which means there's a 3 in one of these 2 cells, which means that... And we know that the 3 is not there because this cage doesn't have a 3 in it. And therefore... Yeah, and then we just repeat the logic on 3s. So now the 40 cage has already got a 3 in it. So it can't have another 3 there. We know red is not 3, so there's a 3 in one of those, which means that's not 3, which means that's a 3, which means that's now red. There we go. That's got a 3 in my 9-cell cage. Oh, but... Okay, but the maths on this is getting a bit difficult now, because this cage down here, which would be the natural place to look next... Well, we know it's got a 3 in it by Sudoku. Well, and we know it's got a 3 in it because this is the only cage in the puzzle that doesn't have a 3 in it. And we know it's got a 1, a 2, and a 3 in it, don't we? Because that's the one that doesn't have a 1. I've got no way of pencil marking this, the sort of negative connotation. There's no 1 in this cage. There's no 2 in this cage. There's no 3 in this cage. Oh, and 4 is the imposter digit, isn't it? And we know there's a... Okay, we know there's a 4 in this cage because it adds up to 45 in 8 cells. So does that mean this has to be missing a 5? I don't know. It might do. Let's just do the maths on it slowly. 9, 8, 7, 6. We know there's a 1, 2 and a 3 in here. Let's put those in. We know there's an imposter. So what's the most we can make this add up to? It would be 36. And replace this with a 9 is 45. Okay. All right. That's very clever. So this has not got a 5 in it, which means there's a 5 in one of these 2. Because there's got to be a 5 in box 9. And there's no 5 in the 45, so that's not 5. So we have a green 5 pair And then this logic works again. Where does 5 go in box 8? Not in these cells, because it's in one of these two. Not in the green, therefore in one of those, which means that's not 5, which means this is 5 and is therefore not green. Good grief. So now I've got my beautiful colouring everywhere. Oh, my yellow colouring is telling me which of the remaining 41 cages is potentially the real cage, i.e. the one that doesn't have the imposter in it. Would have been better if it hadn't been 5 in here, because 5 is not a digit you could ever put on a black dot anyway. So what on earth do we do now? 3 and 5 in my 9-cell cage, which is a little bit suspicious, because that means I can't put 4 on a white dot. Because obviously if you put 4 on a white dot, the other digit next to it will have to be 3 or 5. So what's that telling me? I don't know is the answer. Is there some way I can learn more about the values of these? Obviously I've learned a bit about the blue digits. They have to be 5, 7 or 9. But the reason I learnt this was really from the black dots in the 41 cage, which I don't really seem to have elsewhere. So this is a 41 cage. Sorry, this is a 40 cage. This is also a 40 cage. There's just such a massive amount of freedom in these cages compared to this 45 cage. I feel like there might be a way that I can limit these black dots somehow. Is that a silly thought to have? I don't know. It might be. I know this, right, yeah, I know this cage has 1, 2 and 3 in it, don't I? Because the cages that don't have 1, 2 and 3 are elsewhere in the grid. So this has 1, 2 and 3 in it, but that's not actually that surprising. It'd be quite easy to put 1s and 2s on a black dot. Okay, so now I'm actually stuck. So how do we do this then? I'd love to know how to do this. It feels... What does it feel like? Oh, that can't be a 1, because that would have to be a 2 and that would clash there. So 1 is in one of those 2 cells, 1 is in one of these 2 cells. Oh no, 1, no, that's not right. That's not right. I've got to remember that this is not, I don't know what these are, so I can't assume. Oh, hang on, I can assume. Yes, no, there is, no, I'm wrong. I'm contradicting myself. There is definitely a 1 in this cage. And the reason we know that is there's only one cage in the puzzle that doesn't have a 1 in it, and that's that one. So that 1 must be in one of those 2 cells. So if it was here, we get a 1 here. And then we get a 1 in one of those 2 cells. But is there any real restriction on the value of red? Like, if this was 1, is that somehow not allowed for a reason that I'm not understanding? Don't think that's a problem at all, is it? I don't see why. So, maybe I've got to actually, that's an interesting thought. Maybe I've got to think about the fact I've got to put an odd digit on these white dots. We can think of white dots as because they're consecutive, they must have an odd digit and an even digit on them. Well, the odd digits that go on this one in particular, that cannot be a 1, it cannot be a 3, it cannot be a 5. So the odd digit on this one has to be a 7 or 9. If it's 9, it's got to be 9, 8. But this one could be 1, couldn't it? So that's annoying. Wow, okay, I'm struggling now. If I knew that this cage... That's an interesting thought as well. So I realise that my interesting thoughts are going nowhere at the moment, but I might as well continue to try to have them. If this cage was the one that didn't have a 4 in it, and it could be because we know one of these two cages is the real cage, if you like, with the real cage total, the one that doesn't have an imposter digit in it. If this didn't have an imposter digit in it, then I would know in box 5 there's only one place for a 4. It would have to go there because we can't put the 4 on the white dots. Now that feels like it might be. So how do I prove this one is a lying cage? Would also restrict the value of this cell, wouldn't it? How do we do that? I don't know is the answer. Or is there some reason? Oh, I know what it is. Oh, it's beautiful. It's beautiful and completely eluded me. Right. Okay. The point is that this 40 cage has a 4 in it somewhere. And we know that because the only cages that don't have 4 in are one of the yellow cages. Now, if the 40 cage has a 4 in it, how could you put a 4 in either of those two cells? You can't, because if you do, where are you going to put the 4 in the 40 cage? Because this cell cannot be 4. It's so clever geometrically. It really is. You can't put a 4 anywhere if there's a 4 in one of those. Now, I haven't checked it, but I bet it's the same here. If you put a 4 in there, can you put a 4 in this 40 cage? Of course you can't. Can't go there by Sudoku. Can't go in any of those. They're in the same box as it. So actually, the 4, there must be a 4 in this 9-cell cage. It's ruled out of these. It's ruled out of the white dots. That is so beautiful. Dying Flutchman, that is so clever. So now that's not 4, which means that's not 8. So does that do more than that, please? Please do more than that. It must do something. Well, yeah, I'm tempted to reuse that. Right, so I think what I've learned here is really important. These two cells, you can't put digits in these cells or these cells where that digit has to appear in the 40 cage. Now, what digit do I know appears in that 40 cage? Well, it's got a 1 in it, because the 1 cage in this puzzle, remember there are 10 cages altogether, and we worked out this is the cage that has no 1 in it. So this cage has a 1 in it, so I can't put 1 in here, and therefore I can't put 1 in particular there, which means that now, when we think about where 1 goes in this 45 cage, it has to go on the dot, which means this is a 1-2 pair. now. So now this cell is interesting because that cell is a black dot cell that cannot be 1, 2 or 4. So that's 3, 6 or 8, which means this is 3, 6 or 4. Oh, this is magical. Right, it's not 4 because that's 3, 4, 6 now by greenness, which means these two squares are not 4. So this is a 3, 6 pair, which means this is a 3, 6 pair. No, there's a 3 in there, so this is a 6. This is a 6, this is a 3. Good grief. Oh, I absolutely am in love with this puzzle. This is so clever. That's not 6, so that's not 3. So this is now 4 or 6. Where? Ooh, nearly. Where does 6 go in the 45 cage now? Not... Yeah, in fact, no, that is a good question. Where does it go? I think it's got to go here. We know it's got a 6 in it, and by Sudoku it's got to go there. Which means this, no, it's not 5. I was going to say this is 5 or 7. That's true, except there's 5's down there, so that's 7. Which means that's not 7. So now, if we look at this this big 45 cage, I'm calling it a 45 cage because it's got 9 digits in it. Well, we now know that these cells have got to be 5, 8, and 9 to complete it. We know that's not the 5, so this is 8 or 9. Right, but now let's revisit these black dots at the bottom of the grid, because they cannot involve 3, 6 anymore, so they must be a 1, 2, 4, 8 quadruple, which means that's not 8, which means this is 8 by Sudoku, which means that we're suddenly getting somewhere. 1, 2, 4 and 8 down here, so is that really... So this is a 3, 7 pair now to complete this box. Oh, and that's a 7, so that's a 3, and that's a 7, which means that's no longer a 7. This 3 sees that cell and makes that an 8, which makes that a 4, which makes that have to be a 3, 6 pair. Good grief. Okay. So now this cell can... Oh, I see. Look, this cell here can't be 4 or 8 by Sudoku. So it's a 1 or a 2, which must join. We know that one of these is a 1, 2 pair and one of these is a 4, 8 pair. What we don't have here is a 2, 4 pair. So we can't make this a 2, 4 pair because that's going to make that a 1, 8 pair. So this being 1 or 2 makes this 1 or 2, which makes this 4 and 8, and there's a 4 at the top of the grid. So 4 and 8 go in. Can we keep this going now? Yes, a little bit actually. Look, I've got a 2 pencil marked into these cells and a 2 pencil marked into those cells. So in column 5 and column 6 combined, there will be exactly 2 2s because there's going to be 1 2 in this column and 1 2 in this column. And I know those 2 2s are in those 4 cells, so they're not in that cell as well. That would be a third 2 in 2 columns. So this is a 1, this is a 2, this is a 2, this is a 1, that's a 2 now. I feel like this must matter. 6 here means this is a 6 by Sudoku, this is a 3. There's now definitely a 3 in one of these cells. I might... Can I prove... Oh, nearly. I'm getting really close to proving that this cage doesn't have a 4 in it, you know. Its only remaining position for 4, I think, is there. That sort of feels like it might matter, doesn't it? But, right, that cell's no longer able to be 1. So in this column, this cell here has got to be 5 or 9. Is that useful? I'm going to fill these digits in as well and be a bit pencil mark about this. 3, 5s, 8s and 9s. And what can we get rid of? We can get rid of 8 from this one, and 3 actually. Oh, so that's become a 5-9 pair immediately. That seems very unlikely. Hang on, let me just double check this. 3, 5, 8 and 9. Yeah, I suppose it is true. I have got 3-8 pairs, haven't I? So yes, what I could have seen is that this is a 3-8 pair, and then I could actually have seen that that has to be 8 by Sudoku, which means this has to be 3. That can't be 7 anymore. C's a 7 here, which means that can't be 7. This can't be 8. Oh, look. This has become 4 or 6. So that can't be 9, because it's got to be consecutive. So that's 5, which means that's 5, that's 9, that's 1, that's 7. That's 9, that's 5, that's 9. This is magical. It's ridiculous. It feels a bit unreal. So, good grief. And now, I still don't know what this is. I still don't know if this yellow cage is the real one. It's still got the, apparently it's still got the ability to be incorrect in the sense that it's either missing this digit, which would be a, well, it's not missing that digit. If this is a 6, there is a 4 missing, and this is a correct total. Or if this is a 4, I wonder what total the 4 has to have if this is a 4. I'm just going to check that just in case it feels interesting. So we've got 1135. So if this was a 4, it needs to take the value of 6. Okay. I mean, there's no reason it can't do that, I suppose. Right, what about that black dot? That's not 3, 6 or 1, 2. So it's either 2, 4 or 4, 8. So there is a 4 definitely on this domino, which means that that is definitely not a 3. I imagine what I've got to do here is probably look at the values of these purples or these reds, because of course, because whatever we put in red has to duplicate, effectively we've got quite a lot of digits looking at this red. So just from this row, this cell has to be 4, 6, 8 or 9, but from the column it's not 6 or 8. So it's 4 or 9, and it's not 9 because this cell can't be a 9, so that is a 4. Which means that's a 4. Oh, this is gorgeous. It's just gorgeous. Which means let's take another look at this row. We need 6s, 8. Oh, look, yeah, we need 6, 8, and 9, and that's on a white dot. So that's 8, 9, and that's 6. So 6 is in one of those two cells. Let's now take a look at these two cells to complete this row. 2s, 7s, and 8s is what we need. And therefore, this cell can't be a 2 by Sudoku. And that cell, okay, that seems to be able to be 7 or, yeah, maybe that can be 7 or 8. Right, so we've got 7 or 8 into those squares. And very few, I've not looked at this, oh, well, I can tell you something, oh, that's gorgeous, right, I can tell you something about this white dot. I was about to say, very few white dots unused, and this is true, I think this is the only one we've not studied, but look, it sees 4, 6 and 8. Every white dot has to see an odd and an even digit, so this must have a 2 on it, and if it's got a 2 on it, it can't have a 1 on it, so this is a 2, 3 pair. Which is actually resolved of all things. Therefore, this is not a 2, which gives us a 7, 8 pair. That's a 2, which means that's not a 2 at the top of the grid. There's got to be a 2 into one of those cells now by Sudoku. 5 has to go here by Sudoku using this 5. And therefore, I now know these squares. These have got to be 4, 6, and 9 to complete this box. which I think means these two squares have got to include a 3 for the row, and therefore that's a 3, and therefore this is not a 3, it is an 8, which means that we now know the contents of the bottom row, which are 1, 7 and 9, which doesn't seem to be resolved. 8 I can place in box 3 by Sudoku. 5 is nearly placed in this column. It has to be in one of those two cells because it can't be here. And I think, I might be wrong about this, but it feels like what's left is going to be Sudoku, isn't it? So what we've just got to do is do this with some sort of aplomb, and that will be rather wonderful. But how are we going to do that? Where is the weakness, if there is indeed a weakness in what we've got before us now? 1, 5, 7, 9. I mean, that square's got to be 5 or 9. Don't see it. Okay, let's have a look instead at this row. 1, 4, 5 and 7. Oh yeah, okay, where does 5 go in this row? It's got to go here. So now we're just looking at 1, 4, 7, a snooker maximum, aren't we? Can we do that? 1, 4, 7. That's not 4. That's not 1. This is not 7 of all things. Bother. That's nearly good, but it's not quite good enough. Okay, let's try this column instead. 1, 2, 7 and 9. So that square is 1, 2 or 7 only. And that square has all the options in the world. 1, 2 or 7 or 9. I've got that horrible nagging feeling now that I'm forgetting a rule that would really... Oh, there's a 4 there. That means that's a 6. Ah! So that's quite cool. Not only does that give me a 6 there, but it means that's not 6 as well. But now this cage is the real cage because it doesn't have a 4 in it, so there's no imposter digit. Now that means this cage does have a 4 in it, which is very boring. Well, we know the 4 is in one of those two cells. That's all we know. Okay. Let's check this column where we need 4, 7, 8 and 9. So that cell has got to be 7, 8 or 9, I think. Ah, as does this. Ah, that's got to be 7 or 9. No, there's a 9, 8 pair, so that's a 7. Right, this might be good. Ah, yeah. That means purple is 8, which means that's 8, that's 7, that's 9. So this is 4. We get a 6, 9 pair here. We know this is now 8 by Sudoku. We know this is 9, this is 9, this is 6. We now know this seems to have to be 6 by Sudoku. This 7 tells us this is 4, this is 1. Therefore, this is 7. I think we've done it. I don't want to count my chickens, but it does feel like we're suddenly moving with a bit more alacrity, doesn't it? So these have to be 1, 2, and 9. And that's not 2. And this row still needs 5s and 7s. Can we do that? Probably can. I can't see how. Oh no. It must be resolved, is it not? Oh, bobbins. Right, okay. Alright, let's have a look at this column then. We need 2s and 4s. Ah, and there's a 4 here. So this has to be 4. This has to be 2. Therefore, that look has to be a 1, and that has to be a 9. And therefore, this has to be a 2. Okay, we're not getting any deadly patterns, which I'm very relieved about. We've got to put 3 into this row, which now has to go on this side, which means that's got to be a 7. That's a 7. That's a 1. That's a 1. That's a 9. That's a 5. That's a 9. That's a 7. That's a 2. And if we haven't made a mistake, that's a 5. What a brilliant puzzle that is. Let's click tick. Yay! Absolutely mesmerising. Start to finish, just a wonderful Sudoku with so much weird and interesting logic. The geometry, the idea around there being 10 cages, so we got 9 imposter digits, and then being able to work out sort of the cages that didn't have sequential digits in, and then having to work out that each digit has only one cage it doesn't appear in, and that allowed me to make the progress with the 47 cage. And probably my favourite bit actually was suddenly this revelation that I couldn't put 4 into those cells, and because it would break the fact that I knew there had to be imposter digits in these 40 cages, because my yellow cages were still those 2 at that point. It's magnificent, isn't it? It really is magnificent. It's one of those times where I'm really looking forward to the comments, because I'm not sure how hard that puzzle is. Hard. I think that is hard. I can totally understand why one of the testers had trouble with it. But I know those of you who will have solved it will be just going, wow. Anyway, that's it from me. I hope to see some of you later when we stream the Looker, and we'll be back later as well with another edition of Cracking the Cryptic.